Section 3.3c, Components. In this final section, introducing components, we will look briefly at capacitors, inductors, transformers, switches, transistors, diodes, and integrated circuits. We will look at these components in greater depth in later chapters. Capacitors. To the right here is a schematic symbol for a capacitor. A capacitor is a basic electronic component that stores electrical energy in the form of an electrostatic field. The operation of nearly every electronic system depends upon capacitors, and they vary widely in their size and appearance. And in your textbook there are several pictures of capacitors that you commonly see, and I have put a couple examples of capacitors here that bring out the idea that they vary widely in size and appearance. This capacitor to the right, this is very large, and it is actually a 20,000 volt capacitor, meaning that it could, once it's charged up, it would hold a charge of 20,000 volts. Now to the left is a piece of computer memory, and this is a DRAM module. That's for dynamic random access memory. And DRAM modules are actually built with microscopic capacitors. Now this particular module is a 256 megabyte module. Now a byte holds 8 bits of information, and each of those bits are going to be one of these microscopic capacitors. So if this is holding 256 million bytes, and that's going to be times 8, we would have roughly in the ballpark of 2 billion capacitors on this little piece of RAM. So anyway, this is a comparison that they can be very small and they can be very large as well. And we will formally address capacitors in Chapter 7 of your text. We're just introducing them at this point. Inductors. And here is the schematic symbol for an inductor. An inductor is also a fundamental electronic component, sometimes referred to as a coil. It consists of a spiraled or coiled wire. The inductor stores electrical energy in the form of an electromagnetic field. And here we have some pictures of inductors. Transformers. And again, here's another schematic symbol down here for a transformer. A transformer is basically 2 or more coils whose electromagnetic fields interact. And so here's one coil and here is the other coil. Transformers are used to increase or decrease alternating voltages. Uses include stepping down voltages for use in computers and many other electronic devices. Now, as an example, a personal computer, you plug it into the wall, 120 volts, 60 cycles. But does the computer need that high a voltage? Well, the answer is no. And so the transformer is used to step that voltage down to a much lower level. Actually, the computer is going to operate, the highest voltage it needs is only 12 volts DC. So the transformer will step it down, and then we'll use some diodes to create a device called a rectifier, which will step that voltage down and make it into a DC level. They are also used for stepping up voltages for high voltage applications. So there are some applications where, in the case of, if we're talking about 120 volts, where we would want that 120 volts to actually be a higher level, and the transformer could also step that up. And we will look at transformers in more depth as well in later chapters. Switches. Switches are yet another group of basic electrical devices. Switches break or make circuit connections, and often the term is used, they open or they close connections. And so here we have a picture here, we see a battery, a light bulb, and here is our simple switch. And here the switch is open, and here the switch is closed. So here the connection is broken, and here the connection is made or closed. Then we have a number of different types of switches, and this is by no means all switches, but this is representative of some of the switches that are used in electronic systems. And here we have this first one we'll look at is a single pole, single throw. Now we have this term single pole, single throw. What's that mean? Well, the pole in a switch is the movable part. So here you see this is the part that would move. In fact, in all these switches you can see there is actually a part that will move. The term throw refers to how many circuits are opened or closed during the switching operation. And so in this case there is one circuit here, and it is either energized or it is de-energized, hence the term single throw. Now in this particular one, what we have here, each of these dots indicates a different circuit. And so in this case, this particular pole could activate one of two circuits. So it's a single pole, one movement, but double throw in that it can control two different circuits. And so here is a double pole, single throw. Now here's an interesting one. Here is a double pole, double throw. Over here we have some push button circuits. This one is normally open, this one is normally closed. This one could be maybe a doorbell or something like that. You push the button, momentarily it does something. This one, it's on constantly. You push the button to turn it off momentarily. Then here we have a three-position or three-pole, four-position switch. And so here we have to see 1, 2, 3 different poles, and in each pole there are 4 possible positions. Now the position that this particular switch is in, this connection is made here, and there's a connection here. So currently we have a connection between here and here. But as this rotary switch is turned, we could pick off this connection, this one, or this one, and so hence we have 4 possible positions here. This is the a schematic of a relay. Now this is what you would see in electronics workbench. If you see this key equals A, when you begin using your simulation software, what this would mean is this key equals A means that if you press the letter A on your keyboard, it would cause this switch to activate. Single pole, double throw. Now here we have an actual circuit using a single pole double throw switch. In this circuit S1, okay, S1 is the switch, is a single pole double throw switch. So one possible piece moves, or one movement piece, which is the pole, and double throw means that there are 2 possible circuits that can be activated. And so the idea here is that in this particular position, this circuit is activated and this light is operating. If the switch is activated and we switch it to the other position, then this is activated. So hence the term double throw. Now again, this key equals space here. Again, this comes from electronic workbench simulation software. So what all this would mean is that if you were using this in electronics workbench, if you press the space bar, it would change the position of this switch. Basic switch operation, and this is just a review of what we just looked at. The pole is the switch. The pole in the switch is the movable part. The term throw refers to how many circuits are opened or closed during the switching operation. A double throw switch opens or closes 2 circuits on each pole. Basic switch types include, and this is single pole, single throw, single pole, double throw, double pole, single throw, double pole, double throw, etc. Some switches do not maintain contact when operated and are called momentary contact switches, and these include doorbells, horns, keys on a computer keyboard are examples. Relays. Relays are switches. Okay, the difference is that relays are electromagnetically operated switches. They are used extensively in electrical systems, especially industrial systems. Relays are used for motor control circuits, circuits to protect workers, switching circuits, and power switching. And here we have a graphic image of a relay. Let's take a look here. This relay has double pole, double throw contacts, and you see the contacts are over here. It represents two different switches that change state at the same time. So we could have two different switches wired, or two different circuits connected to this circuit, and they could either be simultaneously connected or simultaneously disconnected. A shows the switch in its de-energized state. Okay, this is A right here. This is de-energized, and B is in the energized state. And if you look closely at this switch, they may look the same, but there's some subtle differences. You'll notice in the de-energized state, you see that we have actually three sets of contacts here. These two are in contact at this. Now this is in the de-energized state. Typically a spring would be holding them in this position. Then down here, this is in the energized state. Now notice here we're applying a power supply, voltage is applied, current is flowing through this coil, and the electromagnetic field is pulling the contact pole, and so now this piece right here has been pulled down to the lower contact. And so now this is in the energized state, and it will stay energized until the voltage is removed, and then the spring will pull it back into the de-energized state. And these are some schematic symbols that you might see for relays, and I'm not going to go into these, but these are just representative of the different types of schematics you might see. The drawings do not always show the relationship between the contacts and the coil. For example, here you see the coil, you see the contacts, but you don't see any, there's no idea of how are these tied together. And that's commonly the way they'll be shown on schematics. And then you see the NC and the NO. The NC means normally closed, and the NO means normally open. This is a programmable logic controller. In fact, there's several of them. These are of the Allen Bradley design. PLCs are small computer systems used to control industrial machines and processes, commonly used in automation. Relays are used in these devices as the switching elements. So these would be controlling various automation functions, and the switching action would be done with relays. Transistors and diodes. Transistors and diodes are solid-state devices or semiconductors. They are used in many electronic devices, including amplifiers, computers, and industrial controls. Diodes are used to alter information signals, convert AC current into DC current, and as a protective device and switch. And here's a schematic symbol for a diode, schematic symbol for a transistor, and here are a number of transistors. Now, we have much more to say about transistors and diodes in later chapters. And then finally, we mentioned integrated circuits. Integrated circuits are miniature versions of complete circuits. Many ICs have more than 1 million components. Okay, that's 1 million transistors, resistors, diodes, inductors, capacitors, etc. And we will look at ICs in much greater depth in later chapters. So this section 3.3, we have introduced many components, and we will be looking at these components in greater depth in later chapters.